Hello everyone, welcome to today's tutorial. In today's tutorial, we are going to look at sample solution to Organic Chemistry Past Questions UCC. Kindly like and subscribe to the channel after watching and press on the notification bell so that when we drop new solutions on the sample past questions, you get notified. So this is a solution to a sample quiz 1 question. And look at the answer. If you have the past questions, you can refer from them. Then look at the answers here. Question 1 was asking that you have to explain why carboxylic acid with 5 or fewer carbons are soluble in water. And the answer is just because they are able to form a strong hydrogen bond with water. So solubility of carboxylic acids in water is just because of its ability to form a strong hydrogen bond. So if there's a strong hydrogen bond formation, it makes it more soluble in water. So carboxylic acid with 5 or fewer carbons, they are soluble in water because their hydrogen bond formation with water is very strong. So that's the answer. The next one was asking you to explain why etanoic acid will exist or will have a molecular weight of 120 in vapor state. And the answer is because when etanoic acid exists in vapor state, it will exist as a dimer. The dimer is, it will exist as 2 in this form. So the molecular weight of one etanoic acid is 60. So when they exist as 2, then it will be 2 times 60, which is 120. So that explains why in vapor state, etanoic acid will have a molecular weight of 120. This is just because it exists as a dimer or exists in dimeric form. Keep note of this word. It exists as dimer. These questions, the remaining questions, you were to draw the structure of the given names. You were given these names and you were being asked to draw the structure. So you have here N-methyl hexanamide and sodium peroxybenzoate. So this is the structure of N-methyl hexanamide. The N-methyl means this methyl is on the nitrogen, then this hexanamide, 6 carbons. Then sodium peroxybenzoate. Peroxy means that it has 3 oxygens, or 1 oxygen extends from the carboxylase ion. The next questions, we were given these structures and we were being asked to name them. So if you see this group, it means it's an ester. And the carboxylic acid portion was this side. And this side is the alcohol portion. So in naming it, the alcohol portion is named as an alkyl. So here this side, the alkyl portion or the alcohol portion is benzyl. Then the carboxylic acid portion is named OAte or an alkanoate. So it is benzoate, but it has a nitrogen at the para position, so it is benzyl p-nitrobenzoate. Very similar to this one. This side is the alcohol portion, which is cyclohexyl butanoic acid, so it's cyclohexyl butanoate. Next, you have been asked to rank these given compounds in order of increasing acidity. And acidity of carboxylic acids are basically dependent on the kind of substituent on them. If the substituents are electron withdrawing groups, they tend to increase acidity. If they are electron donating, they decrease acidity. So with this one, the benzoic acid is a neutral acid or neutral compound, but the methoxy group here is an electron donating group. Then the nitro group here is an electron withdrawing group. So the nitro here will tend to increase the acidity of the benzoic acid, whereas this one will tend to decrease the acidity because it is electron donating. So this is the acidity order, because the nitro group is an electron withdrawing group and this one is an electron donating group. So that's a simple explanation. Let's continue with the other questions. The next question, you were being asked to propose a mechanism between this acyl chloride and this amine. So the reaction or the mechanism between this acyl chloride and this amine is a nucleophilic addition elimination reaction. It's very simple. This nitrogen is a nucleophile, so it will attack the carbon here, and the bond will break to form this intermediate, where the oxygen will assume a minus charge. The nitrogen will assume a plus charge because it has formed excess bond. This one is minus because it has formed less bond. The next one is the oxygen will form its bond back, then the chlorine will be left expelled, so that we form the chlorine ion in the solution and this intermediate. The chlorine ion, once again, is a nucleophile, so it will abstract one proton from this nitrogen, then form HCl with it, so that we get at the end this amide and this HCl. So that's a simple mechanism for the reaction between this amine and this acyl chloride. The next reaction, we are given this one and this one, and you are to show the series of reactions that will undergo in between them to produce this. So you have this as an acyl halide, this side was converted to this side in the question, so you are to propose a reaction sequence for this reaction. So if you have an acyl halide and you add magnesium in ether to it, you are going to get a Grignard reagent, and Grignard reagent can be converted to carboxylic acid by carbonation. You add carbon dioxide in the presence of an acid. This will convert the Grignard reagent to the carboxylic acid. So you are given this and this, and you're being asked to show the reaction sequence that will lead to conversion of this acyl halide to this. Bear in mind, this hydroxy group was not touched, so it was still there. But you have to convert this side to carboxylic acid. Just add magnesium in ether, then you undergo carbonation, then hydrolysis to get the carboxylic acid. Finally, you are given this compound, and you are to show how you can synthesize an ibuprofen. This is a painkiller from it. So we are given this one and this in the question. You have to show how you can convert this one through reaction sequences to this. So as we did in the previous video, if you have a benzene ring, you can do an acylation. You can attach an acyl group by a reaction we call Friedrich-Crafts acylation. Then that Friedrich-Crafts acylation will produce an acylated benzene. If you have this acylated benzene, having this as a ketone group or carbonyl group, you can convert this one to an alcohol by using a reducing agent, sodium borohydride, followed by hydrolysis, or you can also use lithium aluminum hydride, the same reducing agent, which converts this carbonyl group or this ketone group to an alcohol. Next, if you want to generate an acyl halide from an alcohol, you just use hydrogen bromide, a very reactive compound, which will displace the hydroxy and put here the bromine, so that you get this acyl halide. If you have an acyl halide, as we did for the first video, you can just add magnesium in ether to produce a Grignard reagent. Now from here, the Grignard reagent, you can then add carbonation or carbon dioxide, followed by hydrolysis to produce the ibuprofen, which is the painkiller. So in the reaction sequence, we are given from here to here, and you have to show the various steps that are missing, which will lead to the formation of the ibuprofen. So first, you acylate. Second, you reduce. Once again, you add HBr. Then you add magnesium in ether. Then you add carbonation followed by hydrolysis, which is going to give you the final product. So this is a sample solution for sample quiz 1 question. We are going to solve more, so kindly like and subscribe to the channel as we enjoy more of the videos. Thanks for watching.